My name is Dennis Knudsen, and I'm going to cast this webinar here about custom materials in Impact. And my colleague Thomas is also attending. So if you have any questions during the webinar, you can feel free to ask them, and Thomas will try to answer them in the chat. This webinar is taking half an hour, 35 minutes, something like that. And the rough agenda for this webinar is that I will give a quick introduction to custom materials in Impact. What is custom materials and how does the dialog box look like when we open up the custom materials definition? After that, I'm going to create a custom material in 3D Solid in AutoCAD because what you say custom materials that is put into the database can be 3D Solid and will, based on 3D Solid, create the necessary views. After that, I'll of course add the custom materials to the database, Impact database, and this is pretty new. It's possible to get predefined custom materials from PEIKKO using the add-on ProLib from the ProLib add-on to AutoCAD, where you can download it from this page. After I've shown there's two ways to put in the custom materials from PEIKKO, and I will of course show both ways. After that, I will create a MEP Key definition and show how you can make an MEP key with curves. And of course, I will add the custom materials and the MEP key to the element, so we can see how to add on the custom materials. I will also change the custom materials just to show how easy it is to change already made definitions in Impact. So the first thing I'm going to show is this is what you say the element we're going to aim for with the custom materials, how we're going to make it look when we're finished. So here up under the Impact module plan, on the components we have the custom materials and this typical definition. And if we just open up this wirebox here, then we can see that the name of the custom material is wirebox_60. And this name here needs to be unique because this is the name put into the database, so Impact knows which custom material it is. If I open up the wirebox custom material here, we can see it have a description, and this description here is not necessary, neither is the reference. This is just if you want to put extra information on the custom material. And it's possible to get both things shown on the shop drawing and in the custom material table on the shop drawing. On the group, we put our custom material into groups, so it gets easier to find the custom materials when we're going to use them with the draw custom material, so we don't have to scroll through all the custom materials. So this wirebox here is put on the panel connections. The level of detail shows how the custom material is shown. If we're seeing the element in 3D in Solid, then the custom material will be shown in. We will use this 3D view here and put it in if there are a 3D view, of course. Fine is used when we have it in wireframe, and usually we have it in wireframe, so we don't use unnecessary computer, memory and CPU memory. So as often as possible, we have it in wireframe. Down here at the bottom, we can see some size and offsets. This is used to, if we have the dimension type extends, then it will take to these points here, and this is used to calculate the size of the custom material. Up here under horizontal dimension style and vertical dimension style, is it possible to set how the custom material should be dimensioned on on the production drawing, if we want to, on the shop drawing, if we want to, differ this from the project. It's also possible to say if the custom material should cut the reinforcement mesh, and if it should be shown, def should be shown in the annotation text. Let's see if we can make some custom materials to put in this element here. So what I tend to do is when I make my custom materials, sometimes I made a project called standard, something like that, made a drawing here on the other drawings called custom material, and then make a big grid here with all the custom materials with the names, the groups and stuff like that. This is to keep an overview over which custom materials are we having in our standard and stuff like that. It's also easy to go in here, take let's say this fastening plate here and modify it if we already have it in here. But the first thing we need to do is we need to make a custom material based on polylines. So the polylines here should be made into 3D solids, because 3D solids is used when we're putting in our custom material. So what I do is I use my polyline here. I draw half of the bolt down here and close it. And then I will go in and use the automate command revolve, and select the line I should revolve it in around. And of course I want it all the way around here. So now this polyline I draw is now this 3D solid. If we look here, 3D solid. I will also go in and say extrude to this one here, because I want it to be a fastening plate, of course. So now I have these two things here, and I will just move here. I need to 3D rotate it, because when I put it in here on my grid here, and when I put it into the database, I'm going to look here from the top. So when I make my custom materials, I need to make sure that I look from the top when I'm putting it into the database, because impact calculate the views of this custom material here based on the top view when I put it in. So there's a bit different ways to do this. I like to do this a bit more manually, and of course there will be some people that are much better than me to doing this here, but I like to do it in a little more manual way. Let's see here and here, and I want to copy this one here. It's placed here, and this one should be placed up here. So hopefully we will get the right. If we look here, this looks okay. And if I go here and delete all this here. So now we actually have our fastening plate here, and some might argue that you could union this one here into one 3D solid. I tend not to do that, because I think it's easier to modify if I don't do that. And when I put in the custom material here to the impact database, when I put it into my element and stuff like that, with the draw custom material, then it will come in as a block, so everything will be moved together anyways. And this here makes it possible to go in and say I want to modify and I want to move the bolts or something like that. So I think it's easier to not union the whole thing. This one here is finished. We just need to move it up here, but I will make the next thing. This is something in Denmark we call a hornål, and this is a panel connection between two walls. And I'll actually just take this circle here and sweep onto it. So it will be a 3D solid instead of a polyline. This line here is so I know where I want my insertion point when I move it over here. My next custom material here is an electrical box. And I'm going to use the same commands as I did up here and the extrude. So all the custom materials here is actually made from pure AutoCAD. So that's the beauty of the custom materials here in Impact, is that you can make whatever you want and you can make it as detailed as you want. What I think is that you should not make it too detailed, because if you more detailed it is, and you more you're going to show it, or say in solid, then you heavier the project will get. So if you have a really detailed, say loop around here or something like that, with lots of small polygons, then of course it would take a lot more processor memory than if it's more simple. So I have this one here, and I want if I do like this here, move, I want this one here to be rotated. So I have it like this, and these two here should be moved upwards. 29.6, like this. And last custom material here is a strider, something we put in Denmark at the top of the element to connect the slabs and stuff like that onto the wall. So I do my sweep again and select my path. This one here needs to be rotated, 3D rotated, so it's upwards because it's going at the top of the element. So now I have made my custom materials I'm going to use in this project, and I'm going to move this one here, and I want the midpoint between here, and I want the mid here. Move it up here. This one here is going to be moved here. As we can see, I've cheated a bit and also already wrote what my name should be and the description, and what group that should be placed in. As I said, I think this is a good way to keep track of all your custom materials. Of course, this file here might get a bit heavy, but I find it neat to have where you can go in and look on which custom materials you have. So now I'm going to put in here my custom material to my database, and I go up here under components as I did before, take the custom materials like this. Then I'm going to select a new one here, and I'm going to call that 0301 with a description called 10, 150, and 100, like this. So this is a clean sheet. What would you say? I'm starting to say my description is correct. Do I want the reference? Is it from a manufacturer, or is that unnecessary? I want to unnecessary to put in. I want to choose which group I want to put it in. Fastening plate. I'm going to select my level of detail, and when I have it in 3D solid, I always choose for 3D. I go in and select my top view, select the components that should be part of the custom material, press enter, and select my insertion point, and that's pretty easy to find because I have this lines here. Then it's going to ask if I want to create view 2 and 3 from this view. And what Impacts ask is if I want to create view 2 and view 3. I will just say yes to this because I want the other views also. And if I want to create a 2D level of detail for the views, yes. And if I want to, where I want to put the 2D level of details, and I want to put that on fine. So now Impact have created these 3 views and put into the database based on my 3D solid. These views here are quite important because when we're going to put in the custom materials, then are we going to determine how we're going to look at the custom material from the plan drawing and from the shop drawing. So if we go back here to, I'll just press OK here. If we go back to my PowerPoint here, then we can see here that I put up the different views, how it will look from with a wire loop. So when it's from the top, then of course when we look at the front, we will see the loop here. And this here, the views are very important to understand because, as I said, we're going to use that when we put in the custom materials, both on the plan and on the shop drawing. And this is because AutoCAD is a, 2D program, what you call it, then, and it's not that intelligent, and it can determine the views by itself. I put in the AutoCAD cube up here because it's actually the same way we're going to look looking at the custom material if we take the different views. These are the views that are corresponded. But I put in my fastening plate here, and I'm going to put in the other custom materials also. Let's see here, 0701. Like this. I want this one here to be a panel connection. 3D top view. Insert, select the custom material and insertion point. Create view 2 and 3 from this. 2D, and I want to put it under fine, like this. Always change it back to fine because next time you open it up, it will actually start up in the level of detail, and if it's 3D is heavy, then it will take some time to start up the dialog. And we will just do 0801. Put in here on the electrical. Select all the components and create the other views like this. And last but not least, this one here, 0901, 600 millimeter straight on. And this one should be put under other, and let's select the insertion point. And I want to create all the other views from it also. So now I have put all my manually created custom materials into the database. So what we also can do is using this add-on broadlib and the PEIKKO library. As you can see here, if we go to products, we can see all the products they have. If we go into tools, we can see PEIKKO tools, that is StruSoft Impact here. If we click on this, then we can go in and see that PEIKKO offer a selection of precast products for StruSoft Impact. And these are the products that are available. As I say here, please find the zip file below. If I click here, then it will start downloading it. I have cheated a bit and I have already downloaded it, so you don't have to see me download it. In here is a video of my colleague Peter showing how to import the components. And the components here are actually components files that contains each custom material. So if I want to import the wire loop 60 here, then I just download the file and go down here to my components on the project, say import, find my component file, this is the one, and open it. Then we can see here that we're going to import a custom material called PVL60. And of course we want to do that. Import completed. Now I can go into any drawing here on in my project and go in on the, let's say, plan, and go up to my definitions. And then we can actually see here that I have a PVL60. And if I double click on that, we can see that it has the description and the reference called PEIKKO. It does not have a group because it's not created in Impact. And therefore we need to give it a group if we want to do that. Of course, I want to give it a panel connection. If you go in here and see in 3D, it's made in fully solid 3D and no medium. It's also made here on the fine. This one here differ from the other one I've made. We can see here that this one here is at the bottom. This means that it will be inserted, of course, different if other custom materials wire loops are made in a different way. This is quite important that when we create our wire loops and fastening plates and stuff like that, that we always do it in the same way, because otherwise, let's say you have this one here called 60 PEIKKO, this one here at the bottom. If I take this one here, this is at top. So if we're going to, let's say this one here was an 80, and we're going to use both of them in our project and they have different views, then we're going to have to think more about the views every time. And therefore it gets more complicated than necessary to insert the custom materials. So by making the custom materials in the same way and putting them in the same orientation direction every time, then is much easier to work with. So this one here is I cannot use that. So what I'm going to do is I'm actually going to go up here on the lip and the PEIKKO add-on. I'm going here to find my precast wall connection, my wall element connections, and my loop here. And I want this one here. If I change, then I will take download different custom materials here. So I'll just say insert here, and then we can actually see that I'm going to insert my custom material here, and I just want to turn this way. So what I can do now is I can, first of all, I need to explode it, because as you can see here, it's actually a block reference, and I cannot put a block reference into Impact because it will not create all the necessary views out of the block reference. It needs to be a 3D solid. So I will explode it, and when I explode it, it becomes a 3D solid. After that, I'm going to rotate it in 3D like this. And because my hornhole is facing this way, I also want my wire box to have the same orientation. I'll just do like this here. And then I will have to, and then I will move here my wire loop here down to the insertion point like this. Go into my plan, my components, go up here, make a new one called 0702 wire box, let's say 60. Put the wire box here on the panel connections, 3D. I will take the top view, select where my insertion point should be, create the other views from it, also the 2D details. And then we can see here that it comes in as PEIKKO made it. I'll press OK and OK. So now I've made all my custom materials here, and I will have to insert them into my element, also the MEP key using my MEP key here. So the first thing I'll do is I'll go in here under my electric box and say this one here should reference into the one I already made. so I can find it in my definitions. So when I'm going to make an MEP Key Definition, just call it this. And like this. I go in here and I add my, up here on the items, I add my fuga. Oh, sorry, this one here. I will go and select where my key, my box should be, and I want this one here to be at the middle of the element, and I want to have it offset of 500 to the right. I want it to be dimension, and I want it to be in the front of the element. I will add a recess that have a height, width, and counting on 100. The recess should be at the top, and it should just be placed at the insertion point. I do not want that dimensioned. After that, I'm going to add a dock connection. So what I'm going to do is I'm going to say that it should go from my item, from my what do you say, my box to, as it is now, bottom. Can we see here? I wanted it to go to my recess. As we can see here, this is just a line that is an angled line, and I want it, of course, to be nice with curves and stuff. So what I'm going to do is I can right click here and say adjust displacement. And in here we have the possibility to modify how the duct should go. In here there's a couple of different types how we want it to be. We want it to go vertical to vertical. We want it to go from item 1. And we want the distance. So when we go from item 1 here, so the distance is going to be this distance up here. And we want the distance to be, let's say, 900. And the length here is the distance that is angled for the pipe or the duct. Let's say 100. I will change this later. And we want the radius on 100 also. So the 900 is here, and 100 is from here to up here. So this line here is having an angle, so it's the distance is like 100 up here. But I do not like that it's this here. So what I do is I go in and say adjust displacement, and I'll say the length of C should be 0, and it will be more, just say, in 90 degrees angles. I press OK and OK. And the reason why I want this is because my recess is over a window, and I want the box to be at the side of the window. So now I'm going to insert, I will just say wireframe here. Now I'm going to insert my made custom materials into the element. And the way I do this is I go up here and say draw custom materials. I have to choose what type of element I'm going to put in my custom material into. I will say it's a wall. Here it will start under common, and as you can see here, there's a lot of groups under common because we have a lot of different custom materials. If I change this here to my project, then we can see that the groups are actually not that many because we only have these groups in use. And the groups here and the naming and stuff like that does of course differ from company to company depending on how the standard is set up. But I want to put in my plate here. This plate should be at the top of the element. I only want it to be dimensioned in the X direction because it's at the top. I want it to be 2600 from the distance of base. It's because I know that the top of my element is 2600. This up here is the views I was talking about. As you can see here, there's a floor plan drawing. This is how we want to look at the custom material when we put it in at the floor plan. And most of the time now we're putting in at the top of the element. So of course we want to see it from the top. So this is view 1. If it was at the bottom, then it was view 6, and view 1 and view 6 looks a lot alike, and this is of course because it's the same, just from the bottom. So that's why we need to know that view 1 is top and view 6 is bottom. How do we want to look at it at the shop drawing? And we want to look at it from this side because we want the 150 to be along the element. So I just say finish here. I can say that I want to put in my plate here. And as you can see here, my plate is not attached yet. So what I can do is I can move my plate 100 millimeters in, as you can see here. And I can actually go in and say I want to copy my plate here, and I want to do like this here, and move this one here 100 millimeter in also. The custom materials are still not oh, this is not 100 millimeter. This is 75, like this. So when I put in the element custom material here, it's not getting attached to the element right now, because I have to say edit element and add, but I want to wait doing that because I also want some stress in the top of the element. I will draw the stress in a little different way. I want to use this one here called draw multiple custom materials, and this function here allows me to choose a CC distance between the casting materials. And it's a bit easier way to put in if you have many with the consistent distance between. Again, we say group and name. Where should it be placed? It should be placed in the top. And again, we only want the x direction. How far from the distance? 2600. How do we look at it on the floor plan? And how do we look at it at the shop drawing? So now I go in here and say I wanted to start from here, and I wanted to end here. And I can put more so it could go around corners and stuff like that. But I want to do like this here. It asks me for alignment, and this is just an enter also because I don't want to do anything about this, and I don't want to do an offset. And now I can choose fixed spacing or mark spacing. Fixed spacing is fixed. It will always be 600 if I choose that, which I will in a second. Max spacing is the maximum spacing between them, between the custom material. But I'll say fixed spacing. The fixed spacing distance should be 600. And I want the distance from the first one. I want that to start at, let's say, 300. Then we can see that the custom materials are put in here with a start from 300 and a CC distance on 600. This one here is placed in the plate, and of course we don't want to do that. So what I'm going to do is I'm actually going to say at the edge, and I'm going to say that it should start 300 also. So the distance between here is a bit smaller than 600. Now I'm going to add all the components to my element, and if we're going to look at it in solid, then we can see here that my custom material here at the top is also going down in the element, and the plates are looking like this. So if I just try to save my element, so I will add my while loops here at the side. I will add them on my production drawing, and I will also add my MEP key on the drawing. When I work at the floor plan, I have to choose the distance from the bottom to the insertion point. And this is because the floor plan we always look from the top, and that's why we cannot, decide the distance here. When it's on the shop drawing, we have to decide the depth of the custom material because it's in 2D. and we can decide the height, but we cannot decide the depth. So what I'm going to do is draw a custom material, selection my project, panel connections, and take this Y box here. I want to say that it should be in the left side. I only want it in the Y direction because we know it should be at in here in the end cap. How should it look on the shop drawing? And as we can see here, it should not look like this. We want it to be looking like this. And on the floor plan, we wanted to see it from top. And of course, it should be, let's check, it doesn't matter. Let's take this one here. So I'm going to put in here my Y box here, and I want this one here to be 300 from the bottom to my insertion point. And then I can actually, just as I did on the plan, I can copy it and say I want a CC distance here by copying it by 600. This one here is outside the element, and of course I just go and say I want to move this one. Oh, it's not incorrect. Like this, and I want to move it downwards. Let's say 300. What I can do is I can actually go in and use my AutoCAD mirror function here and say I want to mirror these custom materials. What it needs to be aware of is when I mirror here, I need to go in here and say edit custom materials, because things is in the left side. I need to change that to the right side so I get the right thing on the annotation text. And I also need to go in here and change this one here so I know that it will look correct on my plan drawing. Then when I update my element, you can see here it says left side and right side. Go out to my floor plan and update. And we can see here that it's correctly inserted. What I forgot to do is I forgot to insert my MEP key. Let's see what we have here. This one here should be here, and I want, of course, not to be. I will just move it like 100. And update here. So this is actually pretty much the same element now, but let's say we found out that these plates here needs to be changed, and we need to make a new custom material. So what we can do is either we can take a copy of this one and modify it, or we can go in and say I want to draw my custom material. I want to find the fastening plate that is this one here. This doesn't matter. I want to see it 3D like this here, and then put it in here actually, or just put it up here. So as we can see now, this is a block reference. This was what I was talking about earlier. This one here is 3D solids, so I can select every part, each part of it. This one here would get selected everything. So what I do is, just like the PEIKKO custom material, I will explode it. We can see there is some attributes on it. Just delete that, and now I can actually modify here. I can go in and modify and say this one here should be like, let's say 50 longer or something like that. These two here should be moved also. Let's say 25 or something like that. And this is fine. And I can go in and say again, I want to move here, mid between 2 points, and put it down here. Add this one here if you want to have an overview, of course, and then just add it here into my database 0302. Can't remember the size of it. Put in here on the 03 plates, 3D, select the parts just as I did earlier, and insertion point, create all the views. And now we actually have a new fastening plate created just like that. It took me what 30 seconds to make a new one, and that's why I don't union it, because it's much easier to modify. If I had union it, then you have to subtract everything and stuff like that. So when I go in here to my floor plan, I can of course I want to change my plates here. I can either do that by edit it and remove it, but what I also can do is I can actually go in here and say regroup wall. Then it locks up the wall, it's not one block anymore. I can go in and say edit custom material and select my 2 plates. And instead of this one here, it should be this one. Like this. It will be a bit out of the element, that's okay. And when I save my element now, it will get regrouped again, and I cannot select them anymore. And of course go in here and update the element. So all these custom materials here was manually inserted, and it's quite easy to insert manually, but an easier way to do it is actually using custom material templates, which will be the theme of the next webinar. And I will just give you a small teaser on how quickly you can insert all the custom materials here in the edge. So I just go up here, select my wall with my custom material template. Just say I want straighter and wire boxes in the side, like this. And I also want my plates, of course. Like, I don't want to erase the other one. And the plates are put in. So it took like 10 seconds to put all these things in here, what I did manually over here. So this was the webinar about custom materials. I don't know if Thomas answered all your questions, if there were any, but if you need to see this again, it will of course be on our YouTube page. We'll put it up tomorrow or something like that. And I hope you have enjoyed the webinar and you find it useful. Have a nice day.